This is the video lesson for 6.2 Geometry, Properties of Parallelograms. So in this lesson, we're going to use relationships among sides and angles of parallelograms and among diagonals of parallelograms. So to start, a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So you can actually see, here's a picture here. Here's a parallelogram. Opposite sides are parallel here, opposite sides are parallel here. And there's a bunch of theorems involving parallelograms. So here are the first two. If a quadrilateral is a parallelogram, then its opposite sides are congruent, right, by definition. Oh, sorry, that's not by definition, right? If the opposite sides are parallel, then the opposite sides are also congruent. So the fact that they're opposites, both pairs of opposite sides are congruent, are parallel, means that opposite sides are also congruent. And then the next one says if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. And that could be proven using what we know about parallel lines and angles, right? If you can imagine this transversal cutting through these two parallel lines, and these are same side interior angles. So these are going to be add up to 180. And the same thing here, if this is a transversal cutting through these two parallel lines, these two are same side interior angles, and they add up to 180. So consecutive angles are supplementary. So A and B adds a 180, B and C add up to 180, C and D add up to 180, D and A add up to 180. So let's use these theorems in our first problem. It says, what is angle P in this parallelogram, PQRS? And this is this symbol here means parallelogram. So if this angle S is 64, right, consecutive angles are supplementary. So this angle here, angle P, has to be 180 minus 64. So that would be 180 minus 64, 116 degrees, which is C. Okay, so why don't you guys try this next one? It is the same problem, but instead of this being 64, let's make this 86. What would the angle R be if this one was 86? So press pause, see if you can figure that out. You might not even have to press pause. You probably could figure it out right now while I'm talking. And then come back after you've gotten your answer to check to see if you got it right. Okay, again, hopefully you tried this on your own. These two angles are complementary, so if this one is 86, then it's not complementary, sorry, supplementary, right? So they have to add up to 180. So if you take 180 and subtract 86, you get 94 degrees. So that would be your measure of angle R. And hopefully you got that. Okay, go back to that is this theorem that if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So we're going to use that theorem. Moving on, next page. There is another theorem about parallelograms. So if a quadrilateral is a parallelogram, then its opposite angles are congruent. So B and D have the same measure, and C and A have the same measure. So let's see this next problem. It is a proof, yay. It says that we're given that this quadrilateral here is a parallelogram. That's, again, what this symbol means here, parallelogram, A, B, C, D. We want to prove that the angle A is congruent to angle C and that B is congruent to angle D. So we're going to prove this theorem here that we were just given. So we're not going to use that theorem, right? So we're given that A, B, C, D is a parallelogram. So that was given. Okay, and what we do know about parallelograms that we learned on the last page, and we're going to say that angle A, measure of angle A, plus the measure of angle D equals 180. And this is because if it's a parallelogram, then consecutive angles are supplementary. So we can actually write all of those. Measure of angle A plus measure of angle B equals 180. Measure of angle B plus measure of angle C equals 180. And measure of angle C plus measure of angle D equals 180. And we're trying to prove first A and C. So let's find one with A and C. Let's do these two. Since they both equal 180, we can use substitution to set them equal to each other, right? If they're both 180. So measure of angle A plus measure of angle B equals measure of angle B plus measure of angle C. And that's because of, this was 2. This is substitution. And then we can get to, right, we can subtract measure of angle B from both. So the measure of angle A equals the measure of angle C by substitution. Property of equality. And then we also want B and D to be equal. So let's change the color here. This one here, once I can set those ones equal to each other, measure of angle B plus measure of angle C equals 180. Oh, sorry, not 180. We're going to set those both equal to each other. Since they both equal 180, we're going to set the measure of angle C plus measure of angle D together. And that is substitution. And then if we subtract measure of angle C from both sides, we get measure of angle B equals measure of angle D. And that is subtraction, property of equality. Okay, so now we have, we just have one more line here. Since the measure of angle A equals measure of angle C, then angle A is congruent to angle C. And since measure of angle B equals measure of angle D, angle B is congruent to angle D, and that is by the definition of congruence. Okay, wasn't that a fun proof? Okay, and if I went too fast, you can, on YouTube, watch it like slow down. So you can watch it like at half speed or something if I'm going too fast here. So make sure you push pause and make sure you understand all these steps here. Because a lot of these proofs are done the same way. Okay, on. And so now I want you to try your own proof. So here you're going to use this diagram at the right. You're given that AB, this guy, ABCD is a parallelogram, and then AK is congruent to MK. So this is also an isosceles triangle. Okay, so see if you can prove what you're trying to prove is BCD. This guy is congruent to CMD. CMD, this guy. So see if you can figure that out using the proof. So press pause, give it some time, and then check back for the solution. Okay, so here's the proof. Hopefully you got something close or similar. Right, we're given that it's a parallelogram, and then AK is congruent to MK. So that means that since these two sides are congruent in this triangle, this is an isosceles triangle, because that's by the definition of an isosceles triangle. And then within an isosceles triangle, the base angles are congruent. So angle A is congruent to the CMD here, and that's the isosceles triangle theorem. And then we know that angle A is congruent to angle BCD. And that's what we just learned. It's because within a parallelogram, opposite angles of parallelograms are congruent. So by the transitive property of congruence, if CMD is congruent to A and A is congruent to BCD, then BCD is congruent to CMD by the transitive property of congruence. And we're done. Fun stuff. All right, another theorem. Okay, and again, these theorems don't have names. So when you write them in proofs, you actually have to just write the theorem, or you can abbreviate, obviously. Opposite angles of a parallelogram are congruent. So it's so you just have to use a sentence to explain the theorem when you do these. So here's another one. If a quadrilateral is a parallelogram, then the diagonals bisect each other. So they're exciting property of a parallelogram. Right, so here that means AC is cut in half and BD is cut in half. So each diagonal is cut right in half. And we're going to use that property for problem 3. And we're also going to bring in some systems of linear equations from pre-algebra, algebra 1. So let's use that fact to solve this one. Solve a system of linear equations to find the values of x and y in this parallelogram KLMN. And then once we have x and y, we can find km and ln. So let's look at first here this diagonal. Remember, since this is a parallelogram, it's going to cut the diagonals in half. So this means here that x equals y plus 2. And then in this diagonal, we know that y plus 10 equals 2x minus 8. So what we can do is just plug in this. Since x is equal to y plus 2, we can just substitute that in for this x. We can write y plus 10 equals 2 times y plus 2 minus 8. And so y plus 10 equals, distribute this 2y plus 4 minus 8. Y plus 10 equals, we can combine these like terms, 2y minus 4. Then we can subtract y from both sides and get y minus 4 equals 10. Then we can add 4 and we get y equals 14. Okay, and then that means that if we plug this 14 back in, that x is 16. So y equals 14, x equals 16, and then km is y plus 10 plus 2x minus 8, which is, there's probably a quicker way to do this, 14 plus 10, which is 24. So that means, sorry, back here. Okay. 2 times 16 minus 8. So this is 24 plus 32 minus 8, which is 48. Yeah. Okay. And then ln, let's just solve for is x, double x, right? If this is x and this is 16, that means this is also 16. So we can just do 16 plus 16 equals 32. So km is 48, ln is 32, y is 14, and x is 16. Okay, that's how you solve system of linear equations. And I used the substitution method, which is probably your best bet with these ones. So why don't you guys try this next one on the 24 as well? Whoa, what happened? Page on your own. So you can find the values of x and y in this parallelogram PQRS below, and then find PR and SQ. So press pause, set up your system of linear equations, and solve for x and y, and then PR and SQ, and then check back for your answer. Press pause. Okay, here is the solution to this. Hopefully you got that x equals 4, y equals 5, QS equals 10, and PR equals 16. Right, you just have to set, the key here is setting up, right, that this little piece and this little piece are congruent. That's here. Y equals x plus 1, and then this little piece and this little piece are congruent, and you can set them up. 2x equals 3y minus 7 here. And then substitute in your x plus 1 and for your y, solve for x, plug that back in to get y, and then here I just solved, right, y is just 5. So this is, since this is 5, this is also 5, so this whole thing has to be 10. And then this one is 2x, so double x, so this is 8, so this has to be 8. And you can double check that too, 5 times 15 minus 7 is 8. So you can double check that you got it all right by checking, by plugging in lots of numbers. Okay, more theorems. I think this is the last one on this lesson. Yeah. Okay, in this theorem it says, if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So, if in this case, right, these are parallel and these two are congruent, that means these two have to be congruent. Right? Okay, so in this picture, in this figure, we say all of these lines are parallel. AB equals BC equals CD, and they're all 2. This is 2, 2, 2. If EF is 2.25, what is EH? Well, that means this is also 2.25, and this is also 2.25. So from E to H, it is 2.25 plus 2.25, which is 4.5. And that is all that little theorem is. So you can try this one on your own. Please press pause and then check back for your solutions. Okay, not a lot of work to show here. CD is equal to 5. Right, because if these are all 6, and then this whole thing is 15, right, there's 3 different equal parts. So 15 divided by 3 is 5. So this is 5, this is 5, and this is 5, and CD is just this one here. So this is 5. Hopefully you got that. And then here is the homework. Enjoy.